human ML 3D dataset. It is a large dataset with a lot of motion capture data along with texture descriptions. And currently, our system cannot generate virtual memory data for any activities that is not in that dataset. But moving forward, in the direction that we're going into, it's breaking down complex activities into simpler movements. So consider the activity of bench press. We might be able to break it down into lying down and maybe pushing arm outwards. And let's break it down again. We're planning to use LM to break complex activities down into simple movements. And there also is a model that can already take in texture descriptions for simple movements and combine them spatially to generate more complex actions. And that is our plan moving forward.
Mm-hmm. Thank you.
Okay, so I will just follow up to this kind of things. Maybe this is because this is a panel, so we don't want to ask only to you. So,
okay.
So related to, yeah, you go on. So you also talked about some, augmentation things, right? So both of this kind of augmentation, we either using the, LLM or anything else. So maybe, in my feeling, so human activity recognition is not a very, complex compared to other tasks. In the sense that the space is not that big, or the sensor data has not much rich information, right? So this is some of the, in one sense, challenging. But for the data augmentation, if you augment too much, then maybe it might be it might be some not so good all the time, right? So what's your knowledge? What's your insight for the augmentation?
Thank you. Yeah, I think data augmentation, that's, because mainly we use machine learning, definitely we need more data, but we need diverse data, not just from one source, but multiple sources. Like ChatGPT can generate skeleton, and use skeleton generate accelerometer, there are like a bias aggregation, accumulated bias, from one modality to another. So that's why in the YouTube paper, published 2 years ago, you can see when there are more virtual data, it doesn't necessarily contribute to the performance. So you use them, but also that's why I introduced a conv boost. You just like add a sampling layer, resilient layer, and also, of course, data augmentation layer. So for multiple sources. But also you said, activity recognition is a bit simpler. I kind of, not 100% sure because data activity recognition, the definition is a bit blurry. What is activity? We all perform our algorithm on PALM2 data set. But in there, you can see like ascending stairs, descending stairs, and there are walking classes. They are mutually inclusive. To my understanding, like climbing, like ascending stairs, that type of walking. But when we do modeling, because of the ambiguity of the definition of activity, those kind of label bias, subjective label bias are modeled into our model. So I think it's a bit challenging. We have to make it like a concrete. For example, walking detection, what is walking? We have to make a clear definition. And also, is that activity recognition or activity detection problem? Because if that's a detection problem, there's a big long tail problem. Because in lots of data sets, we assume those classes are equally distributed. So, it's a challenging problem.
I just meant to simplify in the sense that the sensor data has less information sometimes.
And also, user might don't want very lots of sensors.
Okay. So do you have any comments on the augmentation? Yes? Then I will go to next question.
So in my opinion, data augmentation is a really good component to put in your HAR pipeline, but I think one must be very careful while doing that, because in our experiments, we found out that in case of SimClear, the performance, especially when less amounts of data was being used, was really bad. And we believe that it was mostly because of something called as cascading augmentation effect. So what happens is that inside your SimClear pipeline, you already have an augmentation module. So if you are extending your small data sets to perform pre-training, you are performing augmentation once, and then inside your SimClear pipeline, you are performing augmentation again. So we found out that this really screws up the performance, and like this is very specific to our paper, but in many of those the applications for HAR, I think there are some instances where augmentations can degrade the performance. So in my opinion, one must be careful while applying them.
Okay, that's good to know that some of the secret of your research works. Okay, let's go to the next question.
So this is a
Gregory,
two-part question.
Yes, please.
You can answer one or the other, or neither. So I want you to say for your work, you have a key insight in all of your work that kind of enables you to go forward. Would that key insight have been possible a year ago? That's the first question. Because I think I know the answer for at least one of the papers here. Then the question is, that key insight, do you think it will be valuable 5 years from now?
Okay.
I tried asking that in the last one. That's a hard question to answer, but we need to be thinking of, as a community, what is the piece of what you've done that will stand the test of time?
We have no time to maybe answer by everybody, but please volunteer. Okay, you will volunteer. Right?
So the answer to the first question, in my field, this work cannot be done like 1 year ago. But this is not because nobody did it. This is because the neuromorphic processor is really new stuff. Like the work, the platform of Louis from Inter, we are using. They released it just 1 or 2 years ago, and now they release. No, yeah, but I mean the Louis 2. The Louis 2 released just maybe at the beginning of this year or at the end of last year. But also another aspect is that not much people, most of people in the spec neural network or in the neuromorphic field is doing the TVS field, still in the computer vision field, and not a lot of people is doing the ubiquitous computing with spec neural network solution. So because my background is neuromorphic, is ubiquitous computing, so when I went to ETH, there's a lot of people talking about the neuromorphic stuff, so I'm thinking if I can combine both. I don't know if...
I'm very sorry. Because this phrase, neuromorphic computing for ubiquitous computing, doesn't make sense to me. What do you mean? Because ubiquitous computing is too vague a term. So what do you mean, neuromorphic for something a little more specific than ubiquitous computing?
What I mean is that, neuromorphic is not a new idea.
No. It's the for ubiquitous computing is what I'm trying to understand.
Yeah.
Because you ended your talk saying you're opening up neuromorphic computing for ubiquitous computing, and I don't understand what that means.
So this, specifically, what I'm doing now is to deploy spec neural network of the low-dimensional sensor data. Before. Most of the work about neuromorphic is based on the computer version, the TVS camera-based data, so it's high-dimensional data. But not too much work is doing deploying the spec neural network on the low-dimensional sensor data.
That's the key phrase.
Yes.
That's a much better phrase than ubiquitous computing.
So as I talked, as follow your work, we are doing some analog to event front end. It's hardware platforms to. So the final goal is to build end-to-end neuromorphic solution for in the ubiquitous computing, like for wearables, for edge scenarios. So this is something new, and nobody did it.
Okay. Anybody wants to answer? Okay.
Yeah, thanks for the question. I think it's a very great question. So for my work, I think the key insight is that like pair collection is most valuable when both models are uncertain about their predictions. So you may argue that this is like a sort of old active learning kind of technique, but I would say like from 1 year ago, we are seeing like a trend, like more and more pre-trained models are being available, and we are trying to get more usages of them. And we can also do some since network devices are also getting more and more. So I think that's why we have this notion of combining existing model with maybe a new modality. I think that's the same is sort of novel in this case. And thinking about 5 years from now, I basically, when I submit this paper, we don't have GPT, we don't have any ChatGPT related stuff. But recently, I've been thinking more about this, and I'm seeing a paradigm shift in this deep learning to large language model and to everything. And people are trying to deal with this domain shift problem by incorporating more and more data into a pre-trained model. However, to me, I think still valuable, not all data are valuable. And there are some data that actually be more valuable than that. And recently, I'm also trying to explore more on Gen AI, especially for networking traces. And I found it will be very useful to use this Gen AI to do more data augmentation, especially on these already valuable data, and try to amplify their effectiveness on the overall model. So yeah, I think that's a trend I'm seeing right now. Yeah.
Okay, I'll take one or two comments for a response from the. But before that, if you have another question from the audience, maybe not. Okay, we can take two.
Thanks.
Okay.
That's a great question. In the interest of time, I'll talk a bit briefly. So my work on procedure tracking, I think the technical insights, like using Bitabi-based algorithm or incorporating human prompts, those are, I would say, not for example, they're not super novel because I got inspired by speech recognition research to apply Bitabi algorithm into our procedure tracking task. But the insight to come up with these algorithms is we have put efforts in this community in making human activity recognition model, and human HAR is now known, and some models achieve very good accuracy. But I found that there's still a gap to apply human activity recognition model to procedure tracking task, and I think in this way, the procedure tracking task is still in an immature field, and in the next few years, I hope this community will put more efforts to make it more accurate so that we can build reliable systems.
Okay. Last one.
Yeah. I'd like to very briefly cover. Thanks for the good question. So my key insight that I started this work is users just blindly use the model without validating the performance. Just briefly recap, my work is about estimating the performance for validating the model after deployment, utilizing only unlabeled data. So thinking of the user's perspective, I believe this kind of performance validation would be more and more important in the next 5 or 10 years than just how to train the model intelligently or accurately itself, because user would because at the end of the day, user is the final user of that model, and user and that aspect, user should know the performance and should understand the performance so that you can, without blindly trusting the model, user might notice that the model might perform worse or might perform significantly fail. So that kind of discussion should be brought into this community. So that's why in my personal motivation to start working on this project, and so I envision that this would be more and more important in the next 5 or 10 years.
Okay, thank you very much. So because of we are running out of the time, we have to go to the poster session now. So you can discuss on the backside, and if you need more time, then please come to the ABC conference in Japan next year. Okay. Okay, let's thank the speakers and the audience for the very good discussion. Thank you very much.
By the way,